All right, so we're still in chapter 6.6. I'm coming back to the story problem, but I want to move on to solving logarithmic equations. So remember, exponential equations are equations where the variable is the exponent, and logarithmic equations are equations that involve logs and variable expressions. So just like with the bases, if we have two logs equal to each other and they're identical logs, then what's inside will be equal to each other, okay? And we can use that information to solve for x in these kind of equations. And then the other thing you need to remember is that when we have a number and we raise it to the log, those will cancel each other out and you just have the variable. So it's called exponentiating, okay? So when we're looking at this one, I can see that they both have the same kind of log. So essentially that disappears and I can solve it by setting what's inside equal to each other. Now this is going to turn into our typical algebra equation. Actually, let me go the different direction. Let me pause this for a sec. Okay, let me go the other direction. Put all my variables on the left side. So I'll start with that. Subtract x, add 7, divide by 3. All right, and for the next example here, note that I don't have the same log on both sides, and this is supposed to read log base 2. It's kind of hidden in there. So I'm going to use that property that exponentiating undoes the logarithm. So this is log base 2, so I'm going to exponentiate by raising each side to the power of 2. So what's written here becomes the exponents and the base becomes 2. So this and this cancel each other out. So I have 5x minus 17 equals 8. Plus 17 plus 17. So 5x equals 25. Now I'm going to divide both sides by 5. And x will equal 5. All right, moving on to the next page. We have some other log problems to show. Now, if you remember extraneous solutions, what happens when we manipulate our equations, we end up solving similar equations, but that aren't exact. So we could end up with x being an extraneous solution. So log of x equals y. Remember that this can never be negative because if we rewrite it as an exponent, this is base 10, or in exponential form, there's no way that you can raise a base to a power and get a negative value, okay? Unless the base itself was already negative, all right? So that means what's inside the log always has to be greater than or equal to 0. So any value in here that's not greater than or equal to 0 will give us a false solution. All right, so we're going to use our log properties. So same logs, and they're being added together. So I can't isolate these. I can't add to one side and get them to look exactly alike. So what I do is I rewrite. So my first step is to rewrite this using my property that says log of m plus log of n is the same as log of m times n. So I'm going to rewrite this so that what's inside can be multiplied. Distribute. So I'm going to have log of 2x squared minus 10x. Okay, now I'm going to exponentiate. Remember, this is log base 10, so I'm going to raise each side to the power of 10. And 10 log of 10 will cancel each other out. So I'm left with 2x squared minus 10x equals 10 squared. 10 squared is 100. Now I'm going to subtract 100 from both sides, so I get a quadratic equation. And now I'm going to solve this for x. Easiest thing to do is to factor out the 2, so divide everything by 2 to make it a little easier to factor my quadratic. Now I need to ask myself, what are the two factors of 50 that when I add them will give me a negative 5? So x times x is x squared, and the factors of 50, that would be 1 and 50, 2 and 25, 10 and 5, and I see, oh yeah, minus 10 plus 5. Double check. Sure enough, the OI factor gives me a negative 5 in the middle, so I'm good to go. Now I'm still trying to solve for x, so now I need to set each one of those equal to 0 and find out that x equals 10 is a solution, and x equals negative 5 is a solution. I should say a potential solution. So now I have to go back and check. Okay, and I'm going to keep rolling down the side of the paper here. When I go back to check, log of 2 times negative 5 will give me log of negative 10. And again, that's not allowed. That would not give me an error on my calculator. Or another way to think of it is 10 to what power gives me negative 10? And I can't do that. There's no way. There's no solution. So this is extraneous. So my answer is this. I'm going to pause for a second. I'm going to show you what it looks like on the screen on Desmos. So what I did is I graphed this, which you can do too if that helps you. And you need to break this into two equations though. The log of 2x plus log of x minus 5 is one equation. Then I set the other side and make it y equals 2, and I look at where they intersect. And you see they only intersect in one place. They don't intersect over here where I have it that x equals negative 5. All right? So that means x equals 10 is my solution. And you guys, you can do that too. If you want to graph it and look for intersections, that works too. That is absolutely acceptable. You just need to remember the solution is the x value. Okay? Going back to the notes, which would be this one. Some more examples. Both have the same log, so I can set what's inside equal and solve. Change colors here. And then just to make sure, just to double check, 7 times 3 is 21. 21 minus 4, well, that's going to give you a positive solution. Okay? If I was to graph this on Desmos, I'm going to pause for a second and then change screen. So here I've graphed the two equations on Desmos. I've made each side a separate equation. All right? And then where they intersect, you can see that the x value is 3, and that was the solution that we came up with when we did it algebraically, 3. That is absolutely acceptable. Looking at number 3 and 4, these are both the same type. So in both of these, you need to rewrite them. That plus sign tells you to rewrite. So this becomes log of 5x times x minus 1 equal to 2. Distribute. Exponentiate each side. Remember, this is base 10, so I'm going to raise each with the power of 10, which means those cancel out. And I'm left with 5x squared minus 5x equal 10 squared. And 10 squared is 100. Now I'm going to make a quadratic equation factor. Or graph it. Again, graphing is a viable solution too. If you're planning on taking pre-calculus, you should learn to do it algebraically, but you can always check your answers using Desmos. It's divided everything by 5 because that's the common factor. Now I'm going to ask myself, what two numbers multiply to give me 20? What are the factors of 20 that would add to give me -1? Then I set each of these equal to 0 and solve them. So 5 is a possible solution. Oops. -4 is a possible solution. Now don't always assume the negative is the wrong one, although in most of these homeworks they are, because you may have a situation where you actually get a -x, but when you plug it back in, it's not a negative value. But you can see here, if I plug this back in and do log of 5 times -4, this is going to give me a -20, so that's extraneous, and that's my solution. Or you can graph it on Desmos, which is absolutely acceptable. In fact, that's how I'm going to do number 4 here. So I'm going to change my screen. Oh wait, you know what? I might not be able to do number 4 that way because I don't know how to do log base 4 on this. Let's see if it'll let me. Underscript 4. Oh, yep, I can. So to do the underscript, you have to go shift and then the underscore, which is next to the plus sign. So log shift underscore 4, move the cursor over. So there's that part. And then I'm going to make the other part its own equation. And I'm going to look for their intersection. So the solution for this one is 4. All right, going back to number 2 here. This is base 2. There are a couple of ways to do this, but I'm going to stick with what your book does, and then I'll show you another way at the bottom of the screen. This is base 2, so I'm going to raise both sides to the power of 2. Those will cancel, so I have x minus 6 equal to 2 to the 5th. 2 to the 5th is 25. I'm sorry, it's not 25. 2 to the 5th is 32. And then I'm going to add 6 to both sides, and I get x equal to 38. Okay, now at the bottom, I'm going to show you an alternative version using my inverse definition. This is the one I usually use just because it's easier for me to remember. This is my base, so I'm going to rewrite this as 2 to the 5th equals x minus 6. So there in one step, just rewriting it using the property that log base b of y equals x if and only if b to the x equals y. So there I have it, right in that one step, and then I go through and solve it. All right, I'm going to do a third video with a couple story problems in it.